In this lab, you are supposed to combine all tools you have learned so far to develop a simple backend system to detect faulty readings by sensors. Your system will work in the offline mode, that is, it uses the collected data over some time to detect faulty measurements in the past. This is the vision. We are going to collect all readings from various sensors and then cross-reference them with each other to detect any possible faulty measurements. We are going to implement this simple solution for that. Assuming that we have 8 sensors, we are going to train an RBF neural network with 7 inputs and 1 output as shown here. In other words, measurements from sensors 1 to 7 are going to be used to predict the readings for sensor 8. After training the system using some historical data, we are going to compare every reading of sensor 8 with what the RBF network is predicting for it. If they are apart for more than 10%, then we assume that the reading from sensor 8 must be faulty. Let's open the folder for this lab and look into its files. So we have several files here. EI fault detector, which is a completed version of what I have shown you in the previous video. Main offline detector, which is the same as what I've shown you before. We have the main fault visualizer, which is a completed version of the video that uses chart.js to show line graphs and mark faults in it. We have 2 test files, test fault detector offline and test fault visualizer, that I'm going to represent to you now. And of course, you are supposed to complete some sections in this EI fault detector to make everything work. So here are the combined data points that I have collected during one of the previous videos. You can use this one, or you can just make one for yourself and just copy it here. And this is the shape of it. So let's compile the project and see how it works. I need 2 terminals. So in the first terminal, I am going to launch the main fault detector. And in the second terminal, I am going to use this fault detector to detect some faulty readings. So as you can see, another file is produced called analysis report. So if I look into it, I would actually see that for sensor number 4, the readings is okay at this specific time. So let's visualize the analysis report. So as you can see, I can visualize the faulty points for sensor number 4. If you go back to the code and look into this test fault online detector, you would actually see how it works. So this is the Axio like before. I'm going to read the data in this combined data points. Then I'm going to use it as JSON. I'm going to pass it on as a training data to my fault detector. I'm going to train it for 100 epochs. And I'm going to have a neural network with only one hidden layer that has 10 nodes in it, and then I'm going to validate my numbers. So in this specific case, the validation data and the training data are the same, except that the validation data is only the first 200 points. So we can see it here. Here's the analysis report, the full analysis report, and I'm just going to show the first 200 points. So as you can see, it only shows false for one of the sensors, which is sensor 4. So your job is to complete this class so that it would detect false for all 4 sensors. To be specific, you need to develop these functions inspired by the single version of it, and in the main you need to call the new functions instead of the one that we are calling now.